Hello everyone and welcome to Venus. We are currently on in my Venus world, where I'm currently doing a series, but this isn't a typical update on the base. In this video we are doing coding and only coding. So we are essentially going to do something here. We are making a very special custom airlock. And that's because I have this winter spawn room here and this winter spawn room down here. And I have airlocks into both of them. And these are just regular old advanced airlock cards running on these. But there isn't really any... well, we don't really need to do all of it. So the thing is, the atmosphere we have here and the atmosphere we have in there are pretty much the same atmosphere, with the only exception that inside here we obviously have hydrogen, and that's why we have the airlock, because we really don't want the hydrogen to go everywhere inside the base. But the airlock doesn't really need to do a complete vacuum and cycle in and do the same on the way out. Basically, we when going into the rooms, we really only need to close the door behind us and then open up, and that's fine. There is nothing in the outside air here that's harmful for the plants. And when going back out, we need to make sure that the hydrogen stays behind. But I really wanted to make the airlock in such a way that I don't have to close my helmet up. Essentially, I want to be able to go through the airlock without a suit on. So we really just need to take the hydrogen out of from the atmosphere in there when exiting. But we can leave pretty much everything else, or leave at least a pressurized atmosphere for us to breathe in while that's going on. So that's what we are planning on making today, a script that does that. And first let's pop outside and see what we got to working, what we have to work with. So now we're outside, and this is the top of the one of the airlocks, and the other airlock is underneath here, and we have a few pipes going here. And the full yellow one, that's just the atmosphere inside here is connected by passive vents to the air inside the rooms. But the regular airlock is connected to that when cycling, and the other side of the regular airlock is just to a passive vent on the other side. And same with this one. But we have two other pipes here. We have the yellow and khaki line, and we have the yellow and white line. So what these are, this is essentially the same atmosphere as the general room, except it's pressurized. Now this line here goes off to some filters inside there. So this pipe is also it's currently connected to a couple of active vents around in these rooms to cycle air and clean out the hydrogen they produce. So we can use that for the airlocks as well. By pumping the airlock air into those, they will automatically go and get filtered. And the white and yellow pipe is basically the output of the filtration unit, but pressurized. And the air in the rooms cycle by being sucked up by the active vents inside the room, and then going off to filtration, and then it gets filtered and gets into this network, and then there's a back pressure regulator over there inside there that just fills it back from this network into the yellow pipe network here, and then it gets distributed around the rooms. And that's essentially the same system we are going to attach the airlocks to. So we'll have an active vent going to this pipe that sucks out the air in the airlock, and then this here we can have an active vent that fills it back up with clean air. But before we start coding, I just wanted to make sure everyone is on the same page. So we'll go through exactly what the airlock should do. We'll just do it manually. I have moved the active vents over to the pipes we just looked at, and I have disabled the screen. So what we want the airlock to do from this stage right now, it's open to the rest of the base. When we go inside and trigger the airlock, we want it to close the door behind us and then basically just open this door. And that's the cycle to get in. And now we have that problem of having hydrogen in the airlock. So the cycle going back out would be to lock the door behind us and then start the active vents. And that should clean up the volatiles, as you can see. And there we go. Now it's no more volatiles here, so we can shut the vents off. And now just open the door to the outside. And that's basically the full cycle. And all we want to do now is just make a program that does all of this automatically for us and make sure that everything goes as it should. So I went ahead and wrote down the initialization, so the aliases for the device connections and some priming of the parameters on the active vents and the doors. So the lock on the active vents isn't crucial, but I like doing it just so that I don't accidentally change anything on the active vents. And the mode on the doors are important. It sets the doors to logic mode, so right now if I click it won't do anything, but that will allow us to detect when a player clicks on the door, and we can use that. But before we really start coding here, I want to cover something about programming style. Usually when you make programs in Stationeers, you'll for example do a start tag and then yield, and then let's say you'll do something, and then you'll do more things down here, and then you jump back to start, right? This is a typical program, and a lot of programs do it like this. But some use cases it's helpful to do it in a slightly different way, which we'll do here. It's especially useful for airlocks, and in automation we'll call this a sequenced program or a sequential function. But a programmer would probably call it a state machine. So instead of doing that, instead of having like a one program loop, we'll have multiple. So we'll just start with listing up all the states the airlock can be in. So we'll have, for example, open to base. That's one state. It's the state the airlock is in currently, right? And then we'll have after open to base, the next state would be closing the door. So we'll just call it closing door. And once the door is closed, once this door is closed, all it really needs to do is just open this door. So we'll call the next stage open to room. And then it will stay in this state until the next trigger, and then once we trigger it back out, the next one would be closing the door again. So we call this closing door 2, just to keep it simple. And then once the door is closed, we'll need to clean the air. And then after cleaning the air is done, it really just has to jump back up to open to base. So we'll just to remember it, we'll do jump open to base. And it's important now that these are our stages. So this is the sequence the program is gonna perform, and each of these are in fact loops of their own, like program loops of their own. So they would all need a yield, yield, and yield, and yield. And then we'll add in conditions and actions for each stage. And that's pretty straightforward. When we are in open to base, like the state it's in currently, what should the states of each door and each active event be? We'll do that first, like what's the actions that it has to be performed within this stage. And really all we have to do is to make sure that this door is open, this door is closed, and the active events are off. That's all we need to do in this stage. So we do set active event open, on 0, and then we set the other active event to be also off. And then we have to do, let's see, we have to set inside door, which would be
hydration critical.
That door. That one would have to be open 0, otherwise aka closed, and then set outside door open 1. So that's basically everything that has to happen in the stage. It's in the stage open to base, right? The state it is in right now. Shut off active events and then set the doors, the one door to open, one door to close, and one door to open. And then we have to figure out what should happen in order to go to the next stage. What are we looking for in order to go to closing door? Well, we're obviously looking for a trigger on the pads here. We want to be looking for when a player clicks on on one of these keypads. And the way to do that is to set the door. Let's see, set inside door. We set the setting to the same number as the open state. So we'll set the inside door setting to 0, and we'll set the outside door setting to 1, which is the same as this open state. And now, after the yield, we can load them back in. So we'll load R0 inside door setting, and we'll load to R1 outside door setting. And now we can see if any of them has been clicked. And we could do, for example, we can see, let's say we'll start with the inside door. Now we have just set the inside door setting to 0, so when a player has clicked it, it will switch to a setting of 1. So we can do a branch greater than 0 for R0. And so that means if it's greater than, we have set it to 0, but if it's no longer 0, so if it will jump to 1. So we can ask if it's greater than 0, in other words 1, we have a player has clicked it, and then we can do a jump to the next stage. And similarly, we can do the same with the other door. We can do, but of course in reverse, because the outside door has a setting of 1. So when a player has clicked it, it will have switched to a 0. So here we'll do a branch. Let's see, branch if equal to 0 for R1 this time, and we still jump to closing door. And if none of these cases trigger, we have not detected a player interaction, so we'll just jump straight back to the same stage. So we now have a complete program loop, and the program will stay in this loop until the player clicks something. Right, and now we can continue with the next thing. Closing to door. Well, obviously active events still needs to be off, but I don't think we really need to repeat it. Similarly, we don't necessarily need to set the settings if we are not expecting to be reading in states while closing the door. So all we really need to do is to set the set outside door open to 0, and that's basically it we have to do here, except we have to make, and now we have to figure out what are the conditions for leaving this stage. If we do jump back here, in what cases should the program leave this stage? And that would obviously be when the door is actually closed. So for that we can do load R0, and we can load the outside door and load the idle. Oops. The idle thing. Hold on. I'll just sip some water here. There we go. Let's see. And if I remember correctly, so it will be when idle reads as 1. It's still operational. So when idle reads at 0, we are done closing the door. So in other words, we need to branch out of this stage when this idle is 0. So we do a branch equal to 0 for R0, and then we branch out to the next stage, and that's basically it for this one. And now we're in the next stage. We are open to the winter spawn room. And what should we do here? Now, here we still want the active events to be off, and I'll just copy these lines just for safety in case the program jumps around a bit. But now we need to really set all the states on the door, because in this stage we'll again wait for a player input, right? So we'll just copy all of these. We'll change the values, but I'll just copy all the lines because we need all of them. And then of course we need to invert all the numbers, so these will have to be 1s and these will have to be 0s, because we are open to the other side in this stage. So that's all we have to do, I guess. And then again, let's do a jump back to the open room, and then we ask what are the criteria for exiting this stage. And like before, we want to exit when a player clicks. So just like before, we'll do a load of the settings. Now it's important that the yield is in between setting the settings and then reading the settings, because this is the time window the player has to interact with it. If the yield was, let's say, up here, it would always read the thing we set, right? That will always be the case. And the same story if the yield was further down. The location of the yield is important. It has to be between setting the settings and then reading the settings. And then we'll also have these, we'll write those out again. So it will basically be the criteria we're looking for will be the same, except again it's inverted because the doors are inverted. So this time we'll read the inner door, but the inner door has a setting of 1, so a player has interacted with it when the setting is 0. So we can do a branch equals 0 again for R0, so this setting here, and then that will jump us to the next stage, and in the reverse for the other one. So branch greater than 0. We could also use branch not equal 0. There we go. That will do the same thing. Let's see. And then we do that for R1, and we jump over to close door again. And then we have the open to the room stage complete. It's doing all it's supposed to be doing, and it's reading the settings and then branching out if we have clicked something. And then we have closing door number 2, and yeah, just like the one before, we really just need to close the door that's open, which will be the inside door this time. And then we have the yield, and let's see, let's do a jump to closing door. And then again, we'll have to read the idle settings for the inside door, because that's the one we're closing. And then again, branch if equal to 0, and then not to open room to clean the air. So that's the closing of the other door sequence done. And now we have the cleaning of the air. And this is the only stage the activants are actually on, right? So we'll copy these and just set them to 1, both of them. So here we are now on both the activants, and I guess that's everything we really need to do in this stage. I mean, we could of course set the doors to open 0, both of them, just to make sure nothing happens. But it shouldn't really be necessary, because we have the way the sequence is going, they should have been closed by now, but I like to add it just for the security of it. But once here, what are the criteria for leaving the base? For leaving this stage, I mean, sorry. Open to base is set here as the default, and it shouldn't be. We should instead do a jump to clean the air. So this is the program loop, and then the criteria for exiting this and then going back up to open to base should be, let's see, load R0. Let's see, and then we have to load from the sensor. We load from the sensor. I guess we'll load the ratio. If I can type ratio volatiles. So that's the volatiles ratio in the room. And when are we done? I guess we're done when this reading of volatile ratio is equal to 0. So we'll do branch equal to 0. So when this is 0, we'll just jump back up and we're done. Let's see, open to base. There we go. And in theory, that's the program. Now, I haven't test run this, so let's just pray. We click the door, and it's open. Well, that's fine and perfect. And then we click the other way. It cycles. And it opens to the outside. It's pretty much exactly what we wanted. And it worked on the first run. Can't get better than that. And yeah, well, that's pretty much the program, I guess. Now, there is one little thing, and you probably noticed it in the video, that it takes a while for the airlock to clean, right? It takes a hot minute, so... well, I think it only takes like 40 seconds, but still. Sometimes that's too long, right? Sometimes you really you kind of need to rush through. So let's add something to this program. Let's take the ship back. So first of all, let's see, this is the cleaning the air. That's the one that takes a long time, right? First of all, I want to add the possibility to cancel the whole thing and essentially regret my decision, and I want to go back in. So let's do that first. So in order to do that, we have to set up the settings again so that we can read the door settings, and we want it for the inside door. We set the setting to the same as the open state, and then we let's see, we can just do it underneath. Load R0. I'm still using R0 here, but that's because we're loading something into it here, and then we're reading what it is here, and after that we don't really care about the value that's stored here. We can just overwrite it, so just reuse the R0 here. And we'll load R0, we'll load the inside door setting. There we go. And then we have set it to 0, so when it's not 0, the player has clicked it. So let's set branch if not equal to 0. There we go. And for R0, and where do we jump now? So we're in the cleaning the air stage. The active events are running, but I have clicked the inside door. I want to get back into the room. So where do we jump from here? And I guess we could just jump straight up to open to room. Just skip to, instead of waiting for the volatiles ratio to drop, we have clicked the door, and we just jump straight to the open to room stage. And this is why I added the active events on 0 here, to make sure that the active events are off, because we can now enter this stage from both up here going down, but we can also take a shortcut if we click the inside door while in this stage. So that should work. I'm not going to test it right now because I want to add one more thing. And that's the same. If we're in the cleaning the room, if I really want to rush out, I want like an emergency overload for it, but I don't want the door to just open. I still want the volatiles to get filtered out. But what we can do is to add a secret stage. Let's call it that. Let's call it, yeah. And in the secret stage, we'll just essentially just vacuum the airlock, because that's much faster than waiting for the volatiles to filter out. And yeah, we can make a vacuum stage, a secret vacuum stage that normally doesn't happen. Let's call it vacuum. And in the vacuum stage, what do we want to do? Let's see. We want to set the active event for going out should be on, and the active event for going in should be off. Well, I'm sorry about the naming here. Active event out means it's taking air out of the airlock, and active event in means it's putting air back into the airlock. So having this one on means that it will eventually just vacuum, and this one is the one that's putting clean air back into it. So with turning that one off, it will eventually then vacuum the airlock. What other things do we need to have here? Not much really. I think that's all we really need to do. And then what's the criteria for what's the thing we're looking for in order to exit this stage? And I guess that would be pretty much the same thing. I mean, we could wait for it to actually be a vacuum, but really we don't need a vacuum as long as the volatiles is still gone, right? So we can just copy this. Probably this will not happen until the airlock is fully vacuumed, but it might happen earlier than the full vacuum, so it might as well just use this criteria, right? And in that case, just jump to open to base, right? So how do we enter this stage? How do we enter this secret vacuum stage? And just like our shortcut up here, we will enter that when we're in the air cleaning stage. We'll enter the vacuuming stage if we click this door again, or click this door while the airlock is running, and that will turn this off, hopefully. So how do we detect the trigger on the other door? I guess we have to set it up like we did on the inside door. We have to set the outside door setting. So again, we set it to 0, the same as the open stage. And now we do our load, our 0. We do outside door settings load. And again, we have set it to 0. So when it's not 0, the player has clicked it. So branch not equal 0 for our 0. And now we can jump to the vacuum stage. And that's pretty much it. So, hopefully, going inside still works. And now we are in the cleaning phase, but yeah, I don't have time for this. I want to go back in. I click this door and it lets me back in. Perfect. And for the other test, I want to close my helmet up. Let's say we're going back out, but we have a rush. We need to get out now. So click that, and then it starts vacuuming. And there we go. Much faster. So I guess that's it. We have a cleaning airlock. An airlock that doesn't necessarily vacuum the thing out. It just keeps the volatiles out, which is exactly what I wanted. So I guess that's it for this video. I'll put this chip on the other airlock as well, but I'm not doing that on camera. So I guess that's it for this video, and I hope you enjoyed some coding with me.